Lesson 6.1 is on ratio and rates. First, let's start off with some vocabulary. Ratio is one of our vocabulary words, and a ratio uses division to compare two quantities. So just like you've done before, it's comparing two numbers to each other. So comparing A to B, or A over B, same thing, any numbers. Equivalent ratios are two ratios, spelling error here, are called equivalent ratios when they have the same value. So if you had 4 over 5, that's an equivalent ratio to 8 over 10. Just like equivalent fractions, you have equivalent ratios. And there are three ways to write ratios. So we can write them, and these are all the same, and they're always read, the ratio of A to B, the ratio of A to B to the ratio of A to B. So you can write it as a fraction with the colon between them or 2. And you should always write the ratio in simplest form. So for example 1, in tennis class you've won 15 out of 24 matches. You have lost 9 matches. Write the ratio in 3 ways, comparing the number of wins to the number of losses. So if we write the number of wins over the number of losses, 15 to 9 is one way of writing it. We can simplify it to 5 over 3. So there's our fraction way, 5 to 3, or using our colon, 5 to 3 would give you the ratio of the number of wins to the number of losses. So I want you to try the following. Using the tennis information from above, compare the total number of matches to the number of matches lost during using a ratio. Write the ratio in 3 ways. Example 2 is comparing and ordering ratios. So in this case, we have 5 to the 11th, 13 to 23, and 3 to 7. We want to put them from least to greatest. So the first step is converting a fraction into a decimal. So we simply do 5 divided by 11 is approximately, and you can round these to the nearest hundredth, is 0.45, 13 over 23 is 0.57, and 3 over 7 is 0.43. Now these decimals are really easy to put in order, because we know 3 to the 7th is our smallest, then 5 to the 11th, then 13 over 23 to get our answer. So I want you to try this using the following ratios, 5 to 12, 8 to 11, and 3 to 5. So press pause now and give that a try. The third example is finding a unit rate. I think this will probably be the most challenging part of this lesson, are the next 2 examples. So if you pay $3.45 for 15 ounces of cereal, what is the cost per ounce? Well, per ounce means that ounce has to be on the bottom. So the cost on top, per, is like the fraction bar, ounce on the bottom. So $3.45 divided by 15 ounces. We can divide both of those by 15, so we cancel out. We want the bottom to become 1 ounce because it's per ounce, which is the same thing as 1 ounce. So we end up getting 23 cents for 1 ounce. So this can be used with many different units. So I put a few examples here. So I want you to find the unit rate of 60 songs in 5 hours, 50 cents in 10 minutes, 113 or $1,315 over 20 people. But remember, for the unit rate, you need to get the bottom to equal 1. So you always want it per a single measurement. So how many songs per hour? How much money per minute? How much money per person? So think like that. Press pause now and give those a try. And lastly, using equivalent rates. So if lightning strikes occur about 100 times per second around the world, how many lightning strikes could occur in 3 minutes? So in this case, they tell us 100 times per second, but we want to get it into 3 minutes. And first we need to just get it into minutes. So we can use this equivalent rate. We know that 1 minute equals 60 seconds. 60 seconds are in 1 minute. We want to get rid of this second on the bottom here. So we're going to multiply by an equivalent rate. But we want seconds to cancel out. In order for seconds to cancel out, that means we need to put the 60 seconds on top since it's already on the bottom. So 60 seconds over 1 minute. Now our seconds are going to cancel out, and we're left with 100 times per minute, but we want 3 minutes. So then we can multiply by 3 minutes, which is going to, the minutes are also going to cancel out, leaving us only with the number of times, and that's how many we want. That's what we want. So we do 100 times 60 times 3, which equals 18,000. So that ends up coming out to 18,000 times. And if we had a value as the denominator, we would divide, but in this case it's 1, so we can end with 18,000 times. So go ahead and give this practice problem a try. Instead of getting $36,000 per day, figure out how many dollars you would get paid in 1 minute. That's the end of this lesson.